Mr. Michael Batu from the University of the Fraser Valley.
Okay, good morning to everybody there in the Philippines watching. And here it's 7 p.m. in sunny British Columbia. So good to be here. And first off, before I begin my presentation, I would like to thank the BSP Research Academy for allowing me to present my co-authored paper for our BSP's International Research Fair. So thank you very much. And also, before I begin, I'd like to mention that if there's any connection I have with the BSP, it's because I have some of my former students who work there and also some of my former classmates. And I'm also glad that we have Dr. Medalla to he was one of my discussants. And the last time I actually met Dr. Medalla was way back when I was an intern at the NEDA. So it's good to see you, sir, once again. All right, so what I'm going to do is I'm going to share my screen with you so that you can see my presentation. So can you see my slides? Is it? All right, let me just, there you go. All right, so the title of our paper is Stay at Home, Macroeconomic Effects of Pandemic-Induced Job Separation Shocks. This is a paper by myself, co-authored with Marcelo Arbex with the University of Windsor and with Sidney Caetano, who's with the government of Brazil. So let me set the context here before we get to the modeling portion, before we get to the nitty-gritty part of the paper. So as of June this year, the U.S. Center for Disease Control and Prevention reported more than 33 million cases of COVID-19. Of course, today these numbers have gone up already, of course. And as of June 1st this year, about 600,000 people died. And one of the most common public health policy prescriptions to reduce the spread of COVID-19 is these mandatory stay-at-home orders. So in the Philippines, we have the different level of community quarantines. In the United States and also in Canada, we have these stay-at-home orders, shelter-in-place, or what they call safer-at-home orders. What this is essentially is that they require people to remain at home except for tasks that are deemed to be essential. So this kind of policy, as we know, has affected the labor market deeply, because workers have been ordered to stay away from their place of work. Some places have, or some workplaces rather, have actually closed down. That has led to an increase in unemployment. In fact, according to Koibyon 2020, this is one of the few peer-reviewed papers that we've cited. Because remember, like, this pandemic is very, very new, and a lot of the literature out there, a lot of them is not yet peer reviewed. So in this paper, we tried our best to cite peer reviewed papers as much as we can. So during the first wave, according to this paper, about 20 million US jobs were lost, and the labor market participation rate had fallen sharply. Okay. So in this study, we look closely into what we call the job separation rate. Okay. So we use data from the United States labor statistics, called the JOLTS, or the Job Openings and Labor Turnover Survey. Okay? So what this is that the JOLTS is about total separations, which include those who quit their work, those who got laid off, or discharged from work, and other forms of separation. Now, you might ask, how is this different from unemployment rate? Remember, when we calculate the unemployment rate, we include people who are actively looking for work. So here in the total separation, we exclude those people. We just capture those people who at that time were separated from their work. And we can see here from the data, this is from the US Bureau of Labor Statistics. We have the US monthly job separation rate on our y-axis, and on the x-axis we have the time. So this is monthly, so we begin our observations from January of 2001 up to May of this year. And we can see here that prior to the pandemic, the job separation rate has been, it increases and it decreases, but pretty much it's quite stable, relatively. Okay, I'm not saying that it's not, that it's stable really, but what I'm saying is that compared to what we see during the pandemic, okay, there I mean, if I was doing research on the job separation rate, let's say 60 years ago, I would say that, oh, this data is fairly, there's not a lot going on here, okay? But now we see this large spike in the job separation rate. This is all because of the pandemic, okay? And in fact, if you look at studies or models developed in the last 60 years, I'm talking specifically about those job search models, the Mortensen, Pisaridis class of models. These kinds of models assume that the job separation rate is constant, okay? Now, because of what we see here, because of the pandemic, there are reasons to suspect that it's not the case, okay? Now, what is driving this, okay? So the pandemic showed us that there are reasons to suspect that it's not exogenous at all, okay? It's not constant. Uncertainty in job separation, so we computed this, okay, measures the size of the deviations of the realized values of the job separation rate from its mean or expected value. So we computed it. Essentially, what this is, people, friends, is that this is what we call a rolling standard deviation. So we borrowed from the finance literature to calculate the volatility of the job separation rate that we see here. Okay, and what we have is this graph that we have here on the screen. So this is the job separation uncertainty index. Okay, so we have indexed this where January 2001 is equal to 100. Okay, and we can see those periods where we have recessions, those periods that are shaded in gray in this graph. We can see that the job separation rate uncertainty index has increased during these periods. Okay, so meaning that during the periods of recessions, there's a lot of uncertainty going on, and that uncertainty is also in the job separation rate uncertainty is also in that. If we were to compare this with the previous graph, I just want to show this one. You can see here that there's nothing really going on here because this is the level of job separation rate. But if we calculate the uncertainty, you will see that indeed during the periods where we have these recessions in the United States, we can see that there is indeed an increase in the uncertainty index. So what we did was we exploited this uncertainty index and used it to inform our model. Okay. Now we're going to get back to this in a bit. All right. So the pandemic-induced job separation rate volatility is very much related to uncertainties affecting labor market dynamics and the overall uncertainty in the economy. Okay. Now, the seemingly random nature of pandemics and consequently of the stay-at-home orders has rendered the job separation rate stochastic. Right? So it's no longer this exogenous thing that we just put there in the model. Like, okay, we're going to say this is exogenous. No, it's not the case. It is stochastic. It has become stochastic. Now, it's important to understand the economic effects of unexpected changes in the job separation rate, okay, which is the first order effect. So if we have this DSGE model, or if you have this textbook model of search, okay, of job search, just take the partial derivative of the job separation rate and then you get the first order effect. But what we're interested in this paper is the dispersion of this effect, the second order, the uncertainty portion of the job separation rate. So we propose a framework. So in this study, we propose a framework that effectively will allow us to disentangle a first order and second order effect of job search, not job search, but job separation rate. Okay. Now, but of course, before we proceed, as any good paper, we need to have empirical evidence. Okay. I mean, we could come up with a theory, okay, and create or write positions or opinions, or not really opinions, but findings from what we have in the model. But it's better if we have empirical evidence. So what we did was, okay, we use VAR, okay, standard, right? So we have a VAR. We did a VAR analysis of macroeconomic variables, okay? And then we included in the VAR model the job separation rate uncertainty index. And so we have a VAR system, okay, and it contains 4 macroeconomic variables. We have the JSR uncertainty, the level of JSR, the unemployment rate, output and consumption. Actually, when I say 4 there, 4 plus the shock. The shock is coming from the uncertainty in the job separation rate. And of course, as standard, it's estimated using OLS, and identification is achieved using a Koleski decomposition. Now let's look at the impulse response. So what we see here is that when there is an increase in the job separation rate uncertainty, that leads to an increase in the job separation rate. Okay, and that of course, and the explanation there is that the uncertainty creates this effect where it reduces the likelihood of employers hiring in the future. Okay, so that job separation rate increases rather, and then you have an increase in the unemployment rate, of course, and a decrease in output, and eventually an increase in the price level. So in the beginning, you see here a drop, but then later on, as the effect of the uncertainty kicks in, we see an increase in inflation in the BAR prediction. So our results suggest that an increase in the job separation uncertainty increases the job separation and unemployment rates and decreases output and consumption. Okay, so precisely one quarter after the job separation uncertainty hits, the job separation rate increases by 0.07 percentage points, the unemployment rate increases by 0.6 percentage points, GDP decreases by 0.01 percentage points, and consumption decreases by 0.008 percentage points. And these observed effects are rather persistent, lasting more than 10 quarters, and are statistically significant at the 95% confidence level. So this part right here, honestly, I'm kind of iffy, this last part about the persistence, because I think the reason why we observe this persistence in the job separation, the effect of the job separation shock, was that in econometrics, we call it an artifact. So it's like an artifact of the data generating process for the job separation rate. So we see earlier that there's some persistence to the job separation rate that has been carried over into this. That's why we see this result. Okay. Now, where does monetary policy fit into this story? Okay, this is where I think this is very, very much relevant to what we're doing here in this research fair. And of course, people at the Banco Central. So in this paper, we asked whether monetary policy in the form of interest rate rules can amplify or lessen the negative effects of pandemic-induced job separation shocks. To do this, we need to come up with a model. So our theoretical framework follows the paper by Leduc and Liu. This one was published if I believe this was a JME, Journal of Monetary Economics. Okay? And in their model, they don't allow for uncertainty in the job separation rate. Okay? And they don't have interest rate smoothing. So for those of you who are familiar with Leduc and Liu model, so you might find this part of my presentation a little bit boring, okay? Or probably a refresher for you. But then for those of you who are not familiar with the model, okay, I'm gonna walk you through this model rather quickly, but I'm gonna try my best to make it as painless as possible. So first is we have a household that chooses consumption and labor supply to maximize their intertemporal utility. Note that in this utility function, we have this H right here. So this H, this is habit formation. So in the benchmark model, we're assuming that this H is 0. And then later on, we're going to relax this to allow for habit consumption and to see whether or not it influences our results. We also have this parameter chi. So this chi captures this utility from working. NT is the fraction of households who are employed. NC is consumption, and then beta is the subjective discount factor. Of course, as any optimization we have a budget constraint. So we have here consumption plus the holdings of nominal risk-free bond divided by PT price level times R, which is the nominal interest rate, plus B over BT minus 1 over PT, plus W is the wage rate. This fee right here is the unemployment benefit, so we include this in the model. And then D is the profit, okay, from ownership of intermediate goods. And T is the lump sum tax paid to government. So the production function is straightforward. It's yj equals xj. So where j are the retailers. Okay. There's a continuum of retailers, each producing a differentiated product using a homogeneous intermediate good as an input. And I'm not going to elaborate further on this monstrosity of an equation, but what I want to emphasize here is that you have this, by the way, this is the profit function of these firms. And omega p is the parameter that measures the cost of price adjustment. So we will calibrate this later, along with the steady state inflation rate. Now, the labor market is characterized by search and market frictions. So in each period, there are NP minus 1 workers and a fraction rho T that is separated from their jobs. Okay. Note here that you see this rho, this is the job separation rate. You see there is a subscript T. So if this was a model of like Leduc and Liu model, they don't have this T right there because it's constant. But here we allow the job separation rate to vary, and that's where the COVID effect comes into play. So unemployed workers UT search for jobs in firms, post vacancies V at a fixed cost. Successful matches are produced via a Cobb-Douglas matching technology, okay, where alpha denotes the elasticity of job matches with respect to the number of searching workers, and mu scales the matching efficiency. Now, aggregate employment evolves according to this equation right here. Again, you see the job separation rate right there, which is stochastic. Okay, the number of unemployed workers searching for jobs in a period T is given by this equation right here, and the unemployment rate is given by this. Now, real wage in this class of models is determined by using Nash bargaining between firms and workers. And the Nash bargaining wage is given by, again, another monstrosity of an equation, equation 8, right? Where I'm just going to emphasize here some of the important parameters here, where B represents the bargaining weight for workers, okay? Kappa is the fixed cost of posting a vacancy, and ZT is the aggregate technology. Okay? Real wages are sticky and adjust slowly to their Nash optimal value. So we have sticky wages in this model. We also have nominal rigidities. Now, the government finances a fixed unemployment benefit. So we go back to the constraint right here. We can see that the unemployment benefit fee, okay, is equal to 1. So phi times 1 minus n equals to t. Okay, and now we get to the important part of the paper, which is relevant to us here, which is the Taylor rule. So the Taylor rule gives us at least mechanically, how the central bank would react if there are changes in prices, if there are changes in output, okay? If output is, let's say, above its target, how will that affect the interest rate? If the inflation rate is outside of its target, how would that affect the interest rate, right? So that's the Taylor rule. For those in the audience who's not familiar with the Taylor rule. So R represents the short run nominal interest rate. Pi is the inflation rate. Pi star is the target rate. YT is real output. Okay, and then we have this R bar and Y bar, which are the steady state in interest rate and output, respectively. Now later on in the presentation, I'm gonna show you that our results are driven by these parameters. So we're going to change the values of these parameters and see how they affect, okay, the economy when we have this job separation rate uncertainty shock happening, of course, induced by COVID. And we have the aggregate resource constraint given by equation 11 right here, okay? And this is also, this part of the presentation is also important because here I'm gonna show you what makes the job separation rate stochastic, okay? So unlike Leduc and Liu, we assume that the job separation rate varies over time. So it follows an exogenous stochastic process right here. So we can see that the standard deviation, sigma rho t right here, has a t subscript. Okay? What it means is that the volatility is no longer constant, meaning that this volatility here changes over time. So we now have this second order shock given by equation 13. Now, in this kind of model, we cannot proceed with the usual methods to solve the model because we're introducing a second order shock. That means we have to do not second order approximations, but we have to introduce third order approximations around the steady state. So here we followed Fernandez and Villaverde, very influential paper on estimating DSG models where we have second order shocks. So I'm not gonna discuss in detail the calibration parameters, the numbers, but all I'm gonna say is that we selected these values to match the U.S. economy. Okay, and the reason why we did that is, of course, because of the availability of data. Okay, I mean the U.S. they have the job separation rate data handily available, so we used their data, and of course, there's nothing stopping us from actually calibrating this model to fit the Philippine economy. Okay, so we can do that as well. So again, we have these other parameters. We have the interest rate rule values right here. These values were taken from other papers taken from the literature. Okay, and then here for the job separation rate, these numbers were obtained from the data. So remember, I showed you in the beginning the job separation rate uncertainty and the job separation rate. So we took data on persistence and standard deviation. We took it from there, and including the persistence and the uncertainty standard deviation. So now let's proceed to the results. So what I'm going to do is I'm going to present first the results of the benchmark model. Okay, and then I'm going to explain the intuition why we're getting those results. Then I'm going to compare how our model performs if we simulate it as if we have a Great Depression type of shock or a Great Recession. So the Great Recession happened in 2008, 2009. Of course, the Great Depression happened in the 20s, and pandemic, what we have now. And then we look at alternative interest rate rules. That is where we change the numbers in the Taylor rule. Then we look at alternative economies. These include when we relax the habit formation and when we introduce flexible prices. And finally, we look at alternative fiscal policy rules. Okay, so what we found was that on the benchmark case, on impact, an increase in the job separation rate leads to decreases in labor supply, the job finding rate, and the marginal value of a worker being employed. So an increase in the job separation rate leads to a decline in value for firms with matched workers and in the value of matches. Now, the combined effects of a contraction in labor demand and labor supply causes a large increase in unemployment, okay, as what we can see here in the impulse response. Okay, so the benchmark here is the black curve right here. So we can see a sharp increase in unemployment. Okay, and ultimately a fall in output and consumption. Okay, as we can see right here, okay, GDP falls. Okay, and also it creates inflationary pressure and a decrease in the real interest rate. So this is what we find in our model. Okay, and then now we ask how the monetary authority responsiveness or lack thereof to deviation of inflation, output, and interest rate to their target values can either amplify or lessen the negative effects of pandemic-induced job separation shocks. Before I forget, actually, I think I forgot to mention in the previous slide, before I proceed to the monetary policy, this blue curve right here, this is for the Great Recession. Okay, this is when we calibrate our model to mimic the Great Recession. And then when we calibrate our model to mimic the Great Depression, we see this red curve right here. Just saying that, of course, the Great Depression was much more severe than what we experience right now, at least using US data. All right, so now let's proceed to monetary policy. So specifically, we consider 6 alternative interest rate rules. Okay, so first is we look at, of course, we look at the benchmark case. Then we look at Leduc and Liu's model. Okay, so in Leduc and Liu, they don't have the interest rate smoothing. And then we look at the case where we have a muted response to output. That means that as if the central bank doesn't care about deviations to output. Strong response to output, which is quite the opposite. So here we maxed, not really maxed out, but we selected a very high value for gamma y, which means that the central bank really cares about output deviation by a lot. Then we look at strong inflation targeting right here. Okay, and in the case of strong inflation targeting, we can see here that gamma y is 0. That means central bank doesn't care about output deviations, but it only cares about deviations of inflation. And finally, we have weak inflation targeting. Okay, similar to the strong, but we just changed the number 5. We change it to 1.2 for gamma pi. So what we found was that the recession triggered by the job separation rate volatility shock is much more severe if the monetary authority is not responsive to output deviations. Okay, the effects observed under interest rate rules that do not respond to output variations are qualitatively similar. So I want to show you the impulse response right here. So here we have the case where the central bank doesn't care about output deviations, which is this this blue. You can see this blue and dotted blue and dotted red curves. Okay. How much time do I have left?
We have 5 minutes.
I think so because I have the timer right here. It says 5 minutes. Thank you so much.
Very good. Thank you.
Right. I'm almost to the end, so we're good. So for the interest rate rules where the central bank doesn't care about output deviations, okay, we can see here that these have the same, like qualitatively similar effects. The dotted red and dotted blue in our impulse response functions. Quantitatively, however, the recession triggered by the job separation rate volatility shock is much less severe if the monetary authority follows an interest rate rule that responds to both the interest rate and inflation deviations, but not output variations. So this can be attributed, as we explained in the paper, to some degree of inertia of the policy rule regarding the deviations of the interest rate in the economy. Okay, so what we did next is as an exercise, and again, for those of you in the audience who would like to learn about modeling, economic modeling, that is, what we do in this case is, as an exercise, we look at changing some of the parameters of the model to see whether or not our results hold. Okay, it's like doing sensitivity analysis or robustness. So allowing for habit formation. So in this case, we allow H to be non-zero. Okay, allowing for habit formation does not substantially change the way the economy reacts to a pandemic-induced job separation rate uncertainty shock. On the other hand, in marked contrast to nominal rigidities, benchmark economy, the recession is more severe in an economy with flexible prices. Okay, so that's the impulse response. And then we also looked at alternative fiscal policy rules. So our theoretical framework permit the analysis of fiscal policy with uncertainty in the job separation rate. So we followed this paper by Gertler, 2008, where we assume a time-varying unemployment benefit. So in the benchmark case, we assumed that the unemployment benefit is constant. But here we're assuming it to change, it's stochastic. Okay? And it's linked to the uncertainty in the job separation rate. Okay, so it's linked by this parameter tau right here. So tau links the pandemic-induced job separation rate uncertainty shock with the unemployment benefit. So as the lump sum tax becomes smaller, that is, as the value of tau becomes more negative, the negative effects of pandemic-induced job separation rate uncertainty shock becomes more dampened. So the lesson here, friends, is that as far as robustness is concerned, our results hold. So even if we have alternative fiscal policy rules, even if we have habit formation in the model, flexible prices, we get consistent results. Okay. So to conclude, before I read the conclusion portion, I just want to mention here that insofar as the monetary policy goes, okay, the kind of monetary policies that we contemplate here are conventional ones. Okay, so if you'll ask me questions about unconventional monetary policy, then it's something that we do not cover in this study. Okay, because we're selling this paper as more of like the relevance of conventional monetary policy during this time of the pandemic. So to conclude, we studied the economic implications of stay-at-home orders and labor market uncertainty to evaluate the role of alternative monetary policy responses to uncertainty shocks. Okay? Now, the source of the uncertainty could be many things, okay? But what we did here was that we attached it to a stochastic job separation shock, described as time-varying standard deviations of innovations in the job separation rate. We find that uncertainty in job separation during the pandemic increased by 42% relative to its level of uncertainty prior to the pandemic. And we show that the severity of the pandemic induced job separation shocks crucially depends on the interest rate followed by the monetary authority. All right, so thank you for your time, and that concludes my presentation.